Okay, guys, so for today, we're going to be looking at the idea of interpolation versus extrapolation, and also finding predicted values we know our line of best fit, or least squares regression line, which we talked about last week. Um, so what I want to do is I want to jump into a question in which we're given some data in which the music industry is constantly chasing and how it delivers music to its listeners. The table below shows the percentage of total US music sale revenues from streaming. Okay. So if you guys look at these values in 2010, 7% of the revenue came from streaming. And in 2015, 34% of the revenue comes from streaming. So when we look at this data, I could think about this in terms of years, or I could think about this in terms of years since 2010. So what I'm going to do is I'm going to take each of these X values and I'm going to turn them into years since 2010. So what you'll see is no longer is 2010, I'm going to say it's 0 because it's 0 years since 2010. And in 2011, we'll say it's 1 year since, and so on and so forth. Now, when we find out what the equation is, which we'll talk about tomorrow, we find it out to be y equals 5.6x plus 4.9, in which x is the number of years since 2010. So I want to use this equation to find some predicted values. So like if I were to follow this model for what should it be? So when we look at data, if there is a strong linear association between independent and dependent variables, or x and y values, you can use a least squares or a linear regression line to make predictions. Using the line of regression to make predictions within the data set is called interpolation. So what does that mean? Well, looking at this data, I can only use this equation between the years of 2010 and 2015 because that's what this data was for. Those 6 years, 2010, 2011, 2012, 2013, 2014, 2015. So if I wanted to find as what my predicted value should be, I'm going to use this equation. So for example, I want to use the equation to predict the percent of streaming revenues in 2013. And eventually what I want to do is I want to compare the predicted value percent with the actual value. So we're looking at 2013, okay? I want to look at the year 2013. So what that means is that 2013 is the same thing as x equals 3. Because remember, x is the values since 2010. So what we're going to do is we're going to plug 3 in place of x. We're replacing the x value with 3. So 5.6 times 3 is 16.8 plus 4.9, which turns out to be 21.7%. So this is saying that in 2013, the percentage of the music industry revenue from streaming is predicted to be 21.7%. So if I wanted to compare the predicted value of percent in 2013 with the actual value, what we're going to be looking at is how does this predicted value compare to the actual value? How does 2013 of 21.7 compared to the actual, which actually was observed? In 2013, the actual revenue was 21%. The predicted was 21.7. So how do they compare? Well, it appears that the predicted is 0.7% higher than the actual. Okay. So let's look at another example in which we look at 2011 and how does that compare to the actual? So we're going to do the same thing we did before. Since we're looking at 2011, we're looking at an x value of 1, and we're plugging that into this equation. So when I do the math, 5.6 times 1 gets me 5.6 plus 4.9 gets me 10.5. So in 2011, the percentage of music industry revenue from streaming is predicted to be 10.5%. So how does that compare, that 2011 10.5% compared to the actual, which is in 2011 was 9%. That's actually what happened. How did the predicted value compare to the actual value? And it appears that the predicted value, once again, is higher by 1.5% than what the expected or predicted or the actual value is. So to make predictions for X values that are outside the data set is considered to be extrapolation. So this data set works for years between 2010 and 2015. If we're looking at extrapolation, it's going to be, we're looking at years before 2010 and after 2015. So anything that's before 2010 is being extrapolated, which means it's outside my range. And 2015 is, anything after it is also considered to be extrapolation. Let's see why. So we're going to look at years 2040 and 2004. So when we look at years since 2010, and this 2040 turns out to be an X value of 30 because it's 30 years after 2010. And if I look at 2004, well, that's -6 before. So if I plug these values into the equation, I get for 2040, 172.9%. And if I look at 2004, I get -28.7. So does this make sense? Like, using the prediction, are they reasonable? Can we use this line for 2040 and 2004? No, it doesn't make sense for us to do that, because in one case, it's more than 100% of the revenue. Well, we can't have more than 100% of my revenue coming from um, streaming services, and we can't have a negative percentage. So in this case, this is a form of extrapolation, because I have to have something between 0 and 100%. And this shows that anything that's above 2015 is going to get me a value that I can't identify as it working. It's an example of extrapolation. And anything smaller than 2010 is not going to work either, because that's going to be, in this case, a negative value. So what you guys are going to be doing is you're going to be asked to identify, I give you guys an equation, and then I'm going to ask you guys to find the predicted value and compare it to what the line of best fit comes out to be, and try to identify if it's an example of interpolation or extrapolation. Have a great day.